In the next few minutes or more, I want to talk to you about how routers learn about different networks, how those networks or which of those networks are installed in the routing table, and how they are used to forward packets. The last part was actually discussed in another video in a little more detail, so you can check that out too. However, to very quickly summarize it, by default, routers forward packets based on the destination IP address and the most specific match in their routing table. Now that we got those details out of the way, we can move on to the context of this video. Now, this discussion will be conceptual and simplified, leaving out some technical detail, so just be aware of that. Now first, let's quickly clarify what a routing table is. It's essentially a database of routing information that contains details such as the destination network, the next hop address or outgoing interface, and some other information which we'll get back to shortly. Now, what routes end up in the routing table, or how is the routing table populated? Well, as said, the routing table is essentially a database of routing information. So it's basically a collection of the best routes that the router knows about. Now, a router can learn routing information from many sources. Perhaps the simplest way a route gets added to the routing table is through a directly connected network. So when a router interface is assigned an IP address with a specific subnet, the router automatically recognizes that it is directly connected to that network. Consequently, it installs a route in the routing table for that network, ensuring that any traffic destined for it is sent out through the appropriate interface. Now, another way to add routes to the routing table is to manually configure them. These are called static routes. Further, dynamic routing is also an option, which means that routing protocols such as EIGRP, OSPF, or BGP advertise routes and exchange routing information. So these protocols handle the route advertisement automatically, and neighbors learn from those routes from each other. Now, what if there are multiple routes to the same destination network? The router must have some way to determine the best of them and install that in the routing table. Pause here and pay careful attention. The same destination network refers to the same prefix, that is, the same network and the same subnet mask or prefix length combination. For example, 10.0.0.0/16 and 10.0.0.0/24 are not the same route, although they have the same base network. So just be aware of that because it is very important to understand that these are different routes. Now, routes to the same destination network can be learned from different routing sources or within the same routing source. For example, the same destination network can be learned from different routing protocols or from different neighbors inside the same routing protocol. The selection process for choosing the best route to be installed in the routing table essentially involves two values. These are the metric and the administrative distance. The metric is used to compare routes within the same routing source. For example, EIGRP could receive routes to the same destination network from different neighbors with arbitrary metrics of 1000 and 2000 to keep the values simple. In such case, the lower metric route is preferred, and in a sense, it is offered to the routing table. So EIGRP essentially is saying that this is my best route to this destination network. Now, the administrative distance is a depiction of the trustworthiness of the routing information source. That's a fancy way of putting it, but basically it indicates what routing source the router trusts the most, or which one it prefers over the others. So now coming back to an example, in addition to EIGRP, let's say a route to the same destination network was available via OSPF. How can the router make a choice between them? The metrics are not comparable because they use completely different algorithms and parameters or values to distinguish the preference between them. So you cannot directly compare EIGRP and OSPF metrics. So the router simply decides which routing source is preferred, and it is identified with the administrative distance value. With default values, EIGRP would be preferred over OSPF, but it is a configurable value, and the order of preference can be adjusted. Directly connected networks are, of course, the most preferred, then static routes, and then come routing protocols in different orders. So to really quickly wrap it up, here are the two key takeaways from this lesson. Number one, the metric value determines the preference of routes within the routing information source. And number two, the administrative distance value determines the preference of routes between routing information sources. I hope that clarifies it for you and you learned something. Thank you for listening.